Okay, now I am going to talk about the types of congruence. As we all know, in any triangle there are three main sides and three main angles. So out of these six items, I need to use only the three pairs, and only the three pairs are required to prove equal of one triangle with the another triangle. In that way, the two triangles can be proved congruent to each other. Okay, so basically the three pairs for congruence of triangles are needed. So we are having different kinds of congruence. The very first type of congruence is SSS congruence, that is side 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 congruence. As the name suggests, we can say that if there are two triangles like we are having right now, the two triangle ABC and triangle PQR, if the side of one triangle is equal to the corresponding side of another triangle, like here I can see that AB is equal to PQ, which is 4.8 centimeter, BC is equal to QR, which is 5 centimeter, and AC is equal to PR, which is 6 centimeter. Okay, so if the three corresponding sides of one triangle are equal to three corresponding sides of another triangle, then we can say that these two triangles are congruent to each other. So for proving the congruence between these two triangles, as we have taken the three sides, so the congruence will be proved on the basis of side 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 congruence. Now we are going to talk about the second type of congruence, that is SAS, that is side angle side congruence. In this, what happens when the two sides of one triangle and the included angle between them? What is the important thing? That the angle we need to take, it must be included between that two sides. Like if I talk about this particular triangle ABC. So if I see that in this 6 centimeter and in this 5 centimeter, which is the angle included, that is angle B. Now if I try to make the alphabetical letter, so it is in which shape? It is in shape V. Okay, now I come to the another triangle, that is PQR. In this also, the side PR is equal to side AB and side PQ is equal to side PC, and the angle P is equal to angle B. Okay, so here also what the letter is, alphabet is being made, that is V. Okay, so if we are going to talk about that, when the two sides and the included angle between them of one triangle is equal to the two corresponding sides and the included angle of another triangle, then only both triangles can be said that they are congruent. And by which congruency, by which three pairs they are congruent, that is SAS congruence. Okay, now here what, for SAS congruence, which letter you need to keep in mind? That is letter V. Okay, you need to check in the given figure that is the V is available. Like here you can see, here V is there and these two sides are equal, and between them the included angle we need to take. Now we can see here, if I am going to make the trace of this triangle ABC, this is A, this is C, and this is B. Now if I am keeping it like this, they are not overlapping. But if I keep it like this, so what I am getting, that Q is overlapping P, A is overlapping R, and C is overlapping Q. So how do I write the congruence relation in this case? triangle ABC congruent to. Now, which is congruent with B? That is P. So P will come in middle. Now, what was congruent with A? You can check A and R are congruent. So at first I will write triangle R, P and Q. If I am orienting them in this way, then only they will be congruent to each other. So this is all about SAS congruence. Here you need to keep the letter in your mind, that is V. Now I am going to talk about third type of congruence, that is angle side angle congruence. Whenever we are taking two angles and the included side of one triangle, and if two angles and the included side of one triangle are equal to corresponding two angles and included side of another triangle, then we can say that both the triangles are congruent by ASA congruence. Now you need to understand what is the meaning of included side and the two angles. For example, suppose this is one strip. Now in this strip, I can see that there are two ends. This is one end. Let us name it as W and let us name it as X. Okay. Now at W, I can make one angle. So I have taken one ray WY. So one angle I have made on W. Okay. Now another angle I can make on X. So it can be XY like this. Now I guess all can understand that what is the meaning of two angles and the included side. I have taken the side WX, and what are the two angles? One is W and another is X. So if such situation is there in one triangle and the same situation you are getting in another triangle, then you can say both the triangles are congruent by ASA congruence. Now I can show you by the activity also. I can take one triangle PQR. Here we can say that PQ is of 5 centimeter and at P angle is 70 degree, at Q angle is 60 degree. Similarly, another triangle is there, triangle ABC, where AB equals to 5 centimeter. Angle A is 70 degree and angle B is 60 degree. So I can see that PQ is equal to AB and the angle P is equal to angle A and angle Q is equal to angle B. So the two angles and the included side. Two angles and the included side is equal, so that these two triangles will be congruent to each other. Then how I will write the congruence relation? Triangle PQR is congruent to triangle. Now what is the angle which is equal to P? That is angle A. So I will write first A, then Q is corresponding and to B. So after A I will write B, then automatically R will be corresponding to C. So in this way I will write the required result by ASA congruence. I can show you by one activity also. You can see this is my PQ. Okay. Now on PQ, at P I will put one side PR. So at P one angle is made, that is here you all can see. Now At Q, again one angle will be made. So Q, R. So on PQ, the two angles are made. One is P, another is Q. Now we can see that PQ is equal to AB. You all can see that PQ and AB are overlapping with each other. Now with A, at end A, I can make angle AC. I can make angle A. So I will put this side AC here. Now at point B, I can put BC. So I will make angle B. Now you all can see that all the three angles and all the three sides are congruent to each other. In that way, you can say that the two triangles are congruent to each other by ASA congruence. Now I am going to talk about the last type of congruence, that is RHS, which is a very special kind of congruence property, and it is always implemented or only applicable on the right angled triangle. Okay, so what its definition is? The definition of it is this, that two right triangles are congruent if the hypotenuse, what is the hypotenuse? The side which is just opposite to the 90 degree in any right angle triangle, that is your hypotenuse. So two right triangles are congruent if the hypotenuse and one side of one triangle are congruent to the hypotenuse and corresponding side of another triangle. Then we can say that both the right angle triangles are congruent to each other. For example, here we have taken the two right angled triangle. The one triangle is ABC and another triangle is PQR. I can see that the hypotenuse BC of triangle ABC is equal to hypotenuse of PR of triangle PQR. Similarly, one of the side AC of triangle ABC is equal to PQ of another triangle PQR. Now, can we say that they are congruent to each other? Let us check with drawing or by taking the trace. So let us do the tracing of PQR. This is Q, this is R, and this is P. Now let us try. No, they are not overlapping. But the thing is that angle Q is right angle in the PQR and angle A is right angle in the triangle ABC. So I am just going to put this Q on A. Yes. Now I can see the two triangles are completely superimposing each other. That means both the triangles are congruent to each other. But in which order? We can see that A and Q are overlapping, P and C are overlapping, R and B are overlapping. So how do I write the congruence relation? From here only I can write down the congruence relation. Triangle ABC is congruent to triangle. Now with A, what is congruent? With A, what is congruent? Q. So Q with B, what is congruent? R. And with C, what is congruent vertex? That is P. So I can say that triangle ABC is congruent to triangle QRP by RHS. Now at the end, there is a special note in the types of congruence. There is no existence of triple A congruence. Now why I have said so? You can see here, right now I am having two equilateral triangle. In triangle ABC, all the angles are given 60 degree, 60 degree and 60 degree. Similarly, in triangle XYZ, all the angles are given 60 degree, 60 degree, 60 degree. That means in both the triangles, the three angles are equal to each other. That means each angle of triangle ABC is equal to each angle of triangle XYZ. But directly you can see without making any trace. You can clearly see that if you make the cutout of or trace of triangle ABC, it is not going to superimpose this triangle XYZ. So when there is no information of the side is given in the congruence, the only on the basis of three angles, you cannot say that the two triangles can congruent to each other. That means A, angle, 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 congruence does not exist.